Hi kids, Miss McQuaid here. So today we're going to talk about something called percent composition. Percent composition tells us that we're looking at how much something is made of. So, percent of anything is the part divided by the whole times 100. So for example, earlier this year we took data on the percent composition of our class. So percent tells you that you should take per means divide by, cent is our prefix that means 100. We know that because we have 100 cents in $1 and we have 100 years in a century. So anytime something is asking you for the percent composition or any type of percent, you know it's going to be out of 100. So let's say that I took data and I said that we knew that out of the 20 kids in our class, 14 of those kids were 15 years old. So if I wanted to know what 14 out of 20 was equivalent to, if instead of being out of 20, it was out of 100, I would set up a proportion that looks like this, where I have 14 out of 20 is equal to x out of 100. Now mathematically, I'm going to have to divide and then cross multiply. So it's going to look like this. I'm going to multiply both sides by 100 so that my 100s cancel out on this side, and I can say that 70% of our class are 15 years old. All percent compositions will look the same, where they will be cross-multiplied by 100. Now, when you take a look at percent composition in terms of mass, what we need to do is think about the mass of the whole substance. Now, when we talk about the mass of the whole, what we mean there is the formula mass. So, if you calculate the formula mass of water, you get 18.02. I'm going to go ahead and make my chart so you can see what I mean and how I solve for 18.02. When I solve for my formula mass, I get 18.02 for the whole mass of all of my water. Now, when I'm trying to determine the percent composition by mass of just the hydrogen or just the oxygen, I can break it up into two parts. So you should write this down. Mass of hydrogen equals mass of oxygen equals. So here I have that the mass of hydrogen is going to be 2.02, which I got from here, the total mass of both of my hydrogens, divided by the mass of the whole thing, which is 18.02 times 100. I'll do that again for oxygen and take the mass of 16.00, which is my total mass for all of my oxygens, divided by the mass of the whole thing, which is 18.02 times 100. Now my percent by mass of hydrogen and my percent by mass of oxygen are going to add up to 100. But for hydrogen, I'm going to go ahead and do 2.02 divided by 18.02 times 100. When I do that, my calculator says that hydrogen is equal to 11.209, and all of those values, and oxygen's percent is 88.7902333074. Now, in terms of rounding, we're always going to round to the hundredths place. So, hydrogen will equal 11.21%, and oxygen will equal 88.79%. Notice that those percentages are going to add up to 100. Now let's try another example. Let's try carbon dioxide. Now, carbon dioxide, let's make our chart. Carbon dioxide is made up of 1 carbon and 2 oxygens. Now look up the masses of each of these elements on the periodic table so we can multiply across. Carbon has a mass of 12.01. And oxygen is 16.00. So that's going to be 12.01 and 32.00 for a total of 44.01. Now, the mass of all of the carbons is going to be 12.01, which I get right here, divided by 44.01 times 100 always. Check your answers and make sure that you've gotten 44.01 for your total, 27.29% for your percent of carbon, and 72.71% for your percent of oxygen. Now on your own, try H2SO4. What is the percent of sulfur in H2SO4? What is the percent of oxygen in H2SO4? All right, now watch video number 2. There's a lot more questions in it. Thanks. Bye.